let's do our first example for rate of change. And this example is going to have three parts, A, B, and C. And we're going to do each one separately as we won't have enough room to do all three at once. So a ball is thrown and its height in meters after t seconds is modeled by h of t is equal to negative t squared plus 2t plus 3. Our first question is, what is the average velocity of the ball between 1 and 2 seconds? So the first thing to note is that they're asking for the average velocity, right? And we know that the average velocity is equal to the slope of a secant between 2 points, and we're given the independent variables for the 2 points. So it's going to be basically rise over run. So we have to find out what the height at time 2 minus the height at time 1, that's like your y2 minus y1, over x2 minus x1. So let's do that on the side here. So what's h of 2 going to be? So if we plug it in here, we'll have negative 2 squared plus 2 times 2 plus 3. That's going to equal negative 4 plus 4 plus 3. The negative 4 and the plus 4 just net out to 0, so we're just left with 3 meters. So the ball has a height of 3 meters at 2 seconds. Now let's find out what's the height of the ball at 1 second. So if we plug it into the formula, what do we get here? We end up getting negative 1 plus 2 plus 3, which ends up being 4. So plugging these values back into our average velocity formula, so h of 2 is 3, h of 1 is 4 over 2 minus 1, which is equal to 3 minus 4 is negative 1, 2 minus 1 is 1, so the answer is just negative 1 meter per second. So that means between 1 and 2 seconds, the average velocity of the ball is negative 1 meter per second. A couple of extra things to note about this question. So the negative velocity just means that on average between 1 and 2 seconds the ball is coming back down. And if you notice as well, the second thing is the units. So it's the average velocity or the average rate of change is in meters per second, because the height, the dependent variable, is in meters and the independent variable time is in seconds. And what was the definition of rate of change? How much is the dependent variable changing per 1 unit change in the independent variable? So be careful with your units here. Make sure that you write them down. Your teacher might dock marks if you don't. Okay, part B for example 1 of our rate of change question. What is the speed of the ball at 2 seconds? What is the speed of the ball at 2 seconds? So speed is the same thing as velocity, and they're asking for it at 1 point in time. So we know that they're asking for the instantaneous speed or the instantaneous velocity, the instantaneous rate of change. So we're going to need a lot of room here, so I'll start closer to the left. So the instantaneous speed is equal to the slope of the tangent. And how do we find the slope of the tangent? Well, we take the difference quotient of f of a plus h minus f of a over h. So let's plug in the correct notation for our question that we're doing. So we're going to find the limit as h goes to 0 of f of the point that we're looking at is 2 plus h minus f of 2 all over h. Now notice how our function is modeled by h, but I'm using f here. The reason is because this h and this h are different. I just realized that, and I don't want you getting confused. But basically, this function, this f, corresponds to this. So we could even write f of t here, just to avoid confusion. So let's do these on the side. So f of 2 plus h, if we plug it in the formula here, we'll have negative 2 plus h squared plus 2 plus h plus 3. So when we FOIL this, when we do 2 plus h times 2 plus h, we'll end up having 4 plus 4h plus h squared. Let's distribute the 2 inside this bracket. So 2 times 2 is 4, 2 times h is 2h, and then the 3 remains there. Now let's distribute this negative 1 in front into the bracket. So negative 1 times 4 is just negative 4. Negative 1 times 4h is negative 4h. Negative 1 times h squared is negative h squared. Plus 4 plus 2h plus 3. Okay, so let's combine some like terms here. The negative h squared is just by itself. There's no other h squareds in the expression. The negative 4h can combine with the plus 2h. Negative 4h plus 2h, that just ends up being negative 2h. And then we have our negative 4, positive 4, and plus 3. Our integers, and they're like terms. So negative 4 plus 4, that nets out to 0, and then we're just left with 3 here. Then let's find what f of 2 is. Plugging it into the equation, negative 2 squared plus 2 times 2 plus 3. So we'll have negative 4 plus 3. The negative 4 and the positive 4 cancel out, net out to 0, and we're just left with 3. So we have our two answers for f of 2h and f of 2. So if we plug those back into here, we'll have the limit as h goes to 0. F of 2 plus h is negative h squared minus 2h plus 3 minus f of 2 is just 3. So we could write a 3 here. And that's still all over h. I'm going to continue this question here. So the limit as h goes to 0. Notice how the positive 3 and the negative 3 cancel out. So we got negative h squared minus 2h all over h. And remember what our goal is here with simplifying the difference quotient. We want to get rid of this h in the denominator. So we would factor out an h from the numerator, and we'll be left with negative h minus 2 all over h. The h's finally cancel out. So we'll be left with the limit as h goes to 0 of negative h minus 2. When we plug in 0 for h, we're just left with negative 2 meters per second. Don't forget the units. We're finding the instantaneous velocity. So the instantaneous speed, or the speed of the ball at 2 seconds, is negative 2 meters per second. So there was a lot going on here, so let's do a quick overview. So they asked for the speed of the ball at 2 seconds, the instantaneous speed, so we got to find the slope of the tangent. We use the difference quotient. Since we're doing it at 2 seconds, the a value is 2. So we found f of 2 plus h and f of 2 on the side here. So f of 2 plus h, we got this. F of 2, we got 3. Plugging those back in here, we did some algebra, factor out an h, the h's cancel out, and we end up getting left with negative 2 meters per second after we plug in 0 for h. Now, one thing about slope of tangent that you could remember, that if in your numerator, especially for polynomial functions, if you're not left with expressions in terms of h, then you did something wrong, because then we can't factor out an h for the h's to cancel out. The whole point is for the h to cancel out in the denominator, and so the constants, in this case the 3's, will have to go away. Part C, for example 1, what is the speed of the ball when it hits the ground? Now, this kind of question, a lot of students I notice don't get it on the test, and a lot of teachers like to put this type of question on the test because there's a lot going on here. You have to really understand what's going on. So what is the speed of the ball when it hits the ground? So the first thing you want to find out is, when does the ball hit the ground? So when it hits the ground, so let's rewrite our equation first. So h of t is equal to negative t squared plus 2t plus 3. When it hits the ground, its height is obviously 0. Okay, so now this is just a quadratic equation that we have to solve. So there's multiple things you could do. You could put this in a quadratic formula. You can factor. I'm going to factor. So the first thing I'm going to do is factor out a negative. So I'll be left with t squared minus 2t minus 3. And then this I could factor into what two numbers multiply to negative 3 and add up to negative 2. Well, that will just be t minus 3 and t plus 1. And that's still always equaling 0. We're trying to find what's the time when the height is 0. So it could either be t minus 3 is equal to 0, so t is 3, or when t plus 1 is equal to 0, or when t is equal to negative 1. Now, since we're dealing with time, t represents time, obviously time can't be negative, so we would disregard this answer. So the ball hits the ground at 3 seconds, okay? Hits the ground at 3 seconds. That's when the height is going to be 0. Okay, so let's reread the question again. What is the speed of the ball when it hits the ground? Well, it hits the ground at 3 seconds, so let's reread it. What is the speed of the ball when it hits the ground at 3 seconds? So they're asking for the speed at a specific point in time, so they're asking for the instantaneous velocity, the instantaneous speed. So since they're asking for the instantaneous speed, we already know we're dealing with a slope of tangent. Okay, and that's just the difference quotient. So the limit as h goes to 0 of f of 3 plus h, because we know it's going to hit the ground at 3 seconds. So we're finding the speed at time 3, minus f of 3 all over h. So let's do these on the side here. So we'll have f of 3 plus h is equal to negative 3 plus h squared plus 2 times 3 plus h plus 3. So that's just going to equal negative. If we FOIL this, we'll end up with 9 plus 6h plus h squared. Let's distribute the 2 in, so we'll have plus 6 plus 2h plus 3. Okay, let's distribute the negative inside, so we'll have negative 9 minus 6h minus h squared plus 6 plus 2h plus 3. Let's collect like terms, so the negative h squared is by itself. The negative 6h combines with the 2h, so we'll get negative 4h here. And then the negative 9, the positive 6, and the positive 3 combined. So negative 9 plus 6 is negative 3, and the negative 3 plus 3 is just 0. So we don't even have a constant term here. And then f of 3, if we plug into the equation, we'll have negative 3 squared plus 2 times 3 plus 3. So we'll have negative 9 plus 6 plus 3, and that just equals 0. And that makes sense because we found out here at time 3 it hits the ground. So obviously f of 3 is going to be 0. So plugging this expression and this answer into our difference quotient, we'll have the limit as h goes to 0. F of 3 plus h is just negative h squared minus 4h minus f of 3 minus 0. Let's just leave it all over h. Let's factor out an h from the numerator. Negative let's factor out an h from the numerator. So we'll be left with h negative h minus 4 all over h. The h's cancel out, and we'll be left with the limit as h goes to 0 of negative h minus 4. So we're left, when we plug in 0 for h, we're just left with negative 4 meters per second, because remember it's speed, rate of change. So what is the speed of the ball when it hits the ground? Well, the speed of the ball when it hits the ground is negative 4 meters per second. So let's do a recap of what we did here. So what is the speed of the ball when it hits the ground? First we have to find out when it hits the ground. So we plug in 0 for h and we solve for t. Solving for t we get 3 seconds. So it hits the ground at 3 seconds. So we're finding the instantaneous velocity at 3 seconds. So we use our difference quotient here. Then we did f of 3 plus h and f of 3 on the side. Then we plugged in our answers back into our difference quotient. We did some algebra, and we ended up getting negative 4 meters per second.